All right, so let's move on to the second section here. So this first statement, which is logically equivalent, I want you to get memorized. So the first step, so we're taking the negation of the conditional. The negation of the conditional. So it's a little challenging, so let's make sure we can go through it. So this says to take the negation of an if P then Q. So notice what it does. It says P, not the negation of P and not Q. So the not this being true, right? And remember what the true of this is. If I show up, then I get the job. Let's just look up for the real true statement. If I show up, then I get the job. The negation would be, the wrong thing would be, I show up and I don't get the job. Does that make sense? The negation of if I show up and then I get the job is I show up and I don't get the job. So that's when it's false, right? So if this is true, this would be when it's false. Okay, just trying to give you an idea, something to kind of push it up against so you understand it. All right, so let's show logical equivalence with the truth table, right? Remember, logically equivalent, get to know those words, means the truth table values are the same. All right, so I've got P and Q going on here. So I'm going to do the true, true, false, false thing, true, false, true, false. Okay, so first I'm going to make up my conditional if P then Q column. So if I show up, then I get the job, true. If I show up and I don't get the job, false. If I don't show up and I get the job, that's true. If I don't show up and I don't get the job, that's true. So those two are vacuously true, remember. Okay, so now let's make a column with the negation of the conditional. Remember, this thing here is called the conditional. So the negation of the conditional. So taking the negation of this, so just taking the negation of each of those. Okay, so now let's work. So this is the left-hand side, right? Right here. Whoops, I tried to make that nicer and I made it uglier. Okay, there's false, right? This is the left-hand side. Okay, so now let's make columns to build up to the right-hand side. So this, I already have P, right? So I just need to make a column for not Q. So this will be false, true, false, true. Okay, so now let's make a column for P and not Q. P and not Q. So P, true, and false gives me a false. True and true gives me a true. False and false gives me a false. False and true gives me a false. So this is the right-hand side. So do these truth table values match? False, true, false, false, check. So I showed equivalence by using the truth tables. Okay, so now we're going to talk about finding the negation of a statement. So I'm just going to go slow through this one. I've got everything written down here just to kind of start walking you through this. So I've got this statement. If x is non-negative, then x is positive or x is 0. Okay, so this has got a lot in here, but I just wanted to go through a big long one and then we'll do lots of little bits. So this is a conditional statement, correct? If then. So that tells me it's a conditional statement. So let's look at what the parts are. So first I have x is non-negative. And then the second part is x is positive or x is 0. So if P, then Q, right? So if I want to take the negation of an if P, then Q, then what I need to do is take P and not Q, right? P and not Q. Okay, so P is x is non-negative. Sorry, I'm going through this a little slower. Okay, so P is x is non-negative, so I wrote that down, and not Q, right? Not Q would be this. Okay, so what I can do, since I've got an or statement here, so I'm going to be taking the negation of an or statement. Does that remind you of De Morgan's? It should, right? So the negation of an R or S, right? So that's why I made this an R and this an S. R and S. So to take the negation of an R or S is not R and not S. So a little bit of everything in this problem, right? Okay, so to take the negation, I would have X is non-negative, right? And, okay, the negation of this is X is not positive and X is not 0. Okay, so let me go back up to the beginning. Notice this is a big deal. So let me write here, big deal. I started with a conditional statement, correct? Now I'm taking the negation of the conditional statement. In the answer, there is no if then, is there? No, there is not. The negation has no if then. The negation has this and something else, right? Because the negation of a conditional is P and not Q. So be careful. So taking the negation of a conditional statement does not give a conditional statement. There's no if then in the answer. This is going to be huge. It's going to be easy to try to stick that in, so don't do it. All right. So when do I get if-thens, conditionals still in the answer? Okay, so the contrapositive, so another word to memorize, contrapositive. So this is logically equivalent. So the contrapositive of if P then Q is if not Q then not P. So I could show a truth table value. I think I'd have you do that in another minute or two or on your problems. But these are logically equivalent, which means they have the same truth table values. If P then Q is the same as if not Q then not P. Okay, so these are errors, and these are common errors. So if P then Q is not the same as if Q then P. So this is called the converse error, right? The converse error where you just switch, right? They just switched the order and tried to say that it was the same. Of course that's not true, right? If it's raining, then I put up my, and I can't think about that right off the top of my head. But anyway, so if P then Q. It doesn't work the other way around. Okay. The inverse error, right? Inverse error is where if P then Q is not the same thing as saying if not P, then not Q. So these are errors that I want you to be watching for and to know.